last presenter before the intermission is Alan Matson, and they're going to be presenting math. Fun, funny, and beautiful, a proof. So let's give it up for Alan.
You never really want to follow the babies, and you never really want to follow the winged monkeys, I don't think. Yeah, welcome to math. I know it's most people's nightmare. It's the horror show that comes just before intermission. But what I really want to show you tonight, I want to infect you with my love of math and how it plays out in my life and how I find the beauty and the fun and the funny in this supposedly horrible concept. But math is the international, if not the universal language. And what we see here is a plaque that was put on the Pioneer space probes, which were the first items to ever leave our solar system. And in this plaque is nothing more than geometry and basic number theory. Not numbers like we see here, which is our base 10 number system, but a base 2 number system called binary. But the base 10 system that we're familiar with allows us to create beautiful numbers such as pi and calculate with them such things as circles and probability and physics. But to calculate, we need objects to calculate with. And I also collect mechanical objects of calculation, primarily slide rules of different shapes and sizes. And yeah, there's a whole society out there that does the same sort of crazy stuff. But if you notice, down here is an object called the curta. And when you love objects like this, what do? Instead of just buying one, you buy one in pieces, 600 and some odd. And you buy watchmaking tools and you put it back together yourself. But the curta was invented by a man named Kurt Herzog, who was in a concentration camp during World War II. And that just shows you that math is really people. And the person you see here is Carl Friedrich Gauss, a mathematician of the 18th and 19th centuries. And we have the normal curve here, which was one of Gauss's creation. And Gauss truly is probably one of the most famous mathematicians of all time. Yeah, that great oxymoron, famous mathematician, according to my wife. But she forgets how many great movies there are about mathematicians. We see here various folks who have done everything from game theory to number theory to, heck, sending folks to the moon and actually teaching kids calculus. So how can you say that it's an oxymoron? And then there's like the top 10 lists. Everybody's got their top 10 of, songs of the year. I have my top 10 equations. And it's not the same top 10 that every mathematician would have, but these are 10 that I find especially interesting and which I've found enlightening over my love of math. One of them is pictured right here, creates this amazing beauty. There's nothing more than addition and multiplication going on in this equation, and yet it creates such a fantastically beautiful image, the Mandelbrot set. Simple calculations can lead to amazing beauty, but not just simple calculations, but also simple manipulations. Take a belt, twist it 1/2 time, put it together, and you've created the Mobius strip. And the version we see here with the ants crawling around it was created by M.C. Escher. These ants will soon learn that there's only one side to this Mobius strip and only one edge. But also simple types of math like algebra can be extended to create beautiful scenes like this. Here we have 9 representations of how the symmetry and motion can occur of a 4-sided figure called a tetrahedron. This branch of math comes, as I said, straight from algebra, known as abstract algebra. But abstract algebra does more than create beauty. It creates a pastime for me. Yeah, I collect Rubik's Cubes. And yes, that's an original from the 70s that I had one when I was a kid. Now, I'll be honest, the one in the upper left is actually called the Ghost Cube. I've never quite been able to solve. But here we have applied symmetry. And what we have here is symmetry in action. These images all come from one of my favorite buildings in the world, the Alhambra. The Alhambra is the great Moorish palace in Granada, Spain. And the Moors and the Islams were great at math. They gave us the word algebra, algorithm, and Arabic numbers. Oh, we got to get to some proofs here. Now, I don't know if you can tell this, but this is actually a proof of what happens when you add up numbers. And do you notice that we're adding up numbers? We're using arithmetic. And what we use for the proof is a rectangle and 2 triangles, and then we apply some unknowns or algebra, connecting 3 areas of math. But we don't just do it with counting numbers, we do it with odd numbers as well. 1, 3, 5, 7, 9, add up to 25, another square number. So think about it tonight. Add up the numbers 1 through 20 and see what you get. I'm sorry, add up the first 20 odd numbers and see what you get. Has something to do with 640. But not all these visual proofs are quite so simple. I mean, it should be obvious here what's going on. By the way, it was obvious to Carl Friedrich Gauss, who came up with this proof. But once again, it's numbers, it's geometry, and it's algebra, showing us how easy it is to cut a pizza into 17 exactly same pieces. And this is math today. Gauss was the 1800s. This is today. This picture comes from the New York Times from 2 weeks ago. A group of collaborative mathematicians asked the question, how many ways can we actually divide a square into 5 similar rectangles? Never been asked before, but using, again, algebra and other aspects of math able to prove it. But math occurs where you might not expect it. All 3 of the players in these scenes are using math. They're using game theory. Left, right, center, where do I go? Bet, fold. What do I do? Raise? Poker players and soccer players are using game theory continuously. Aha! The word problem. We have to have the word problem before we leave our math. If you can get 4,000 oranges into the red car, 2,000 oranges into the silver car, and you have 2 men moving oranges from the, well, wait a second. We don't really need to do this. This is not what tonight is about. We need the proof. And the proof of what an excitement about math can do is right here. For the last 15 years, I've been volunteering in the Burlington middle schools, teaching a math enrichment program called Math Counts. And 3 of the kids here are 3 of my many who have gone through my program. And I hope I've infected them with the love of math, shown them some of the beauty and some of the fun, just as I hope I've been able to do tonight with you all. Thank you very much.